Now let's look at using the multiplication algorithm. Let's say I'm doing something big. Let's go 5,142 times 4. So I'm going to write this out by putting the 5, 1, 4, 2. I don't want it to be too close together. I'm going to put the 4 down below. I want the shorter number to be down below. So start off, go 4 times 2. 4 times 2 is 8. We put that's in the ones column, so we'll put that there. 4 times 4 is 16. Now we can put the 6 there, and that 1, well, in a way it's kind of here, but we're going to boost it up here. So we know there's a 1 there, but we want to add that on later. So 4 times 1 is 4, but we'll plus that 1 on, and we'll get 5. Now 4 times 5 is 20. Put the 0 there, and the 2, we can put it there now. But why does the multiplication algorithm work? So we're just doing essentially the same thing as the area model, we're just neatening it up a bit. But sometimes that splitting into the place value isn't really obvious of well, that's what we're actually doing here. What we're doing here, as we times the 3 by the 5, and the 3, the 2 and the 6, we're actually going 3 times 5, 3 times 30, 3 times 200, 3 times 6,000. So essentially we're turning into 6,000 times 3 plus 200 times 3 plus, let's go down here, 30 times 3 and then plus the 5 times 3. So this is a fundamental understanding of multiplication, that we can break these numbers up and then put them back together again, and you still get the same answer. So we've got 6,000 threes, then we're going to add on 200 threes, 30 threes, and 5 threes, and add them all up together. And all up, we've got 6,235 threes. But sometimes we can lose a sense of what's happening there because of where the numbers go here. So let's just rub this out. So when I do 3 times 5, and I get my 15 here, so that seems quite simple, that I'm carrying that 1 over. But when I do 3 times 3 here, and adding on that 1, and I'm putting that number here, well, actually what we're doing is that's 3 times 30, and our answer is going to be 90. And when we put that 9 there, although we're going to add that 1 on later, when we're putting that 9 there, it's actually 90. And we've already got that 5 taking the place of the 1s there. So 3 times 3, and that adding on that 1, that's 10, putting that 0 there, putting that 1 over. 3 times 2, that's going to be 3 times 200. And so, and plussing on that 1, it's going to be 700. And we can see that now, it's kind of like, there's a 700 there, and we just got the 5 there, adding on from before. And 3 times 6, 18. But really it was 3 times 6,000, and our answer was 18,000. And then it all kind of slots in neatly here. But behind this is a key understanding of place value and how it can make multiplication a lot easier. Now what about if we had longer numbers for the multiplication algorithm? Let's say we had, let's go with 56 times 789. So I'm going to put it into my algorithm. I want the longer number on top. 7, 8, 9. Now technically it could work on the bottom, but we'll have to do it completely differently. So let's not do that. Let's put 56 on the bottom now. 56. And make sure we've got these clear columns there. So we'll do it like we did before, 6 times 9, so that's going to be 54. Put the 4 there. Now, in a way, we're putting the 5 there, but we're just going to keep it up here in reserve. 6 times 8, so that's going to be 48, plus the 5, 53. Put a 3 there. Now the 5 is going to go up here. 6 times 7, that's 42, plus the 5, 47. Put the 7 and put the 4 there. So now we're going to be timesing by 5. So we started with the 1s, now we're going to go over to the 10s. So in a way we're not actually timesing by 5, we're timesing by 50. Timesing 789 by 50. And we know when we times something with a 0 on the end, we can take that 0 off and then put it back on later. Because we know there's going to be a 0 on the end, let's put that 0 there now. And now when I do 5 times 9, and that's going to be 45, I'm going to be starting here. Because we know eventually there'll be that 0 at the end because it's a 50. 45, and now this is where it can get a little bit confusing keeping track. So I might cross these out now, and I'm going to put my 4 there, just so I don't get confused between the 4 and the 5. That was the 45. 5 times 8 now is 40, plus the 4 is 44. That's going to go in that next column that's available. 44, we put that 4 over there. 5 times 7, that's 35, plus the 4, that's 39. So everything that we're doing with the 5 was shifted over by 1. Now we need to add these together. So this top one, that was 789 times 6. This bottom one is 789 times 50. So it's similar to what we would have done with the area model, and that idea of breaking the numbers up. Let's add them together now. 4, 3 plus 5 is 8. 7 plus 4 is 11. Put the 1, carry that other 1 over. 1 plus 4 is 5, plus the 9, 14. Carry that 1 over. 1 plus 3 is 4. Our answer is 44,184.